Hi, Doc Revis here with Watch Me Work It. Bond energy and bond association energy. Let's do some calculations. What is the bond energy of each of the following molecules? Okay, to do this, the bond energy in a molecule is simply a combination or the composite or the sum of all the bonds involved. So we have to count the bonds and check them against the standard tables and see what energies we have. So let's do that. So in this particular compound, which happens to be diethyl ether, we count the bonds. We see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 CH bonds. So let's put the CH bonds. So for CH bonds, we have 10 of these. And the energy in a CH bond, we look on the table, is 413. So we write that value in there. And next we have some carbon bonds. So CC bond. So for the CC bonds, we see we have 1, 2 CC bonds. And so we'll say we have 2 here times the bond energy in these from the table. So we see the C on the table is 348. So we'll put that number in here, 348. And next we see that we have CO bond, carbon oxygen bond, and we have 2 of these because we have 1 carbon oxygen bond here and 1 here. And so that's going to be 2 of those. And let me just back up and clear a little space here. Okay. And so that's going to be 2 of the CC bonds. I'm sorry, 2 of the CO bonds. And the carbon oxygen bond is 358. And so if we take these and we add them all up, do the appropriate arithmetic there, and you add them up, you'll get 5,542, and the units of kilojoules per mole because that's what it was on the table. So that's it. That's the bond energy for the first one. Let's do the one on the bottom here, which happens to be ethanol. So in this case, we see we have 1, 2, 3, 4, 5 CH bonds. So for the CH bonds, we have 5 times the number of kcals in that, number of kcals in this is 415, plus, what else do we have? We have CC bond, and we only have 1 of those, so that's 1 times 348 for that, plus what else do we have? We have a CO bond. Let's put that in there, CO bond. How many CO bonds? We have 1 CO bond, so it's going to be plus 1 CO bond. The value in a CO bond is 464. All these values are on standard tables. And so we do that. We get this. Plus, we also have an OH bond in this one. We have to count for all the bonds, so we want to know the total energy in it. And it's going to be, I think I may have put the wrong number here for CO. Let's back up and get these numbers right here. This actually, I'm going to switch places with these two. Just put it wrong. I'm going to put the OH right here. 1 OH bond and 1 CO bond. There we go. Now we have a 1 CO bond. It's going to be, the order that you put them in doesn't matter. Just I made a typo there. So we put this, we add them together. And for this, put it all together and we get 3,593 kilojoules per mole. Okay, so that's what we get for this. Now if we go up to water, here let's just do water. And in water we only have oxygen and hydrogen bonds. So we have an HO bond there, and we have 2 of them. So this is going to be just 2 times the values of that. That's not too challenging. And that's going to be 92.8 kilojoules per mole. And if we go up to CO, this is going to be 2 times the energy in a CO bond, which is right here. We have 2 of those. So 2 times that value, 2 times 805, is going to give us 1610 kilojoules per mole. Okay, so that's how we find the energy in the bonds of a compound. We simply take the energy of each of the bonds and we add them together. Okay, and that energy being kcals per mole. All right. So let's do a problem where we look at the bond dissociation energy. Now, it's all related, but in the case of the bond dissociation energy, you really want to know how much energy is involved when these bonds basically break, if you will. They dissociate, and we do that by, in this particular case, we're going to carry out a reaction of diethyl ether and oxygen, basically going to combust it. So what's the bond dissociation involved here? Now, with bond dissociation energy, you have to remember that bond dissociation energy is going to be the bonds broken, or the enthalpy, or in the bonds broken, bonds we break. Let's back up. I'll write that again for you. It's going to be bonds broken. So this is going to be the sum of all the bonds broken minus the sum of all the bonds we produce or we make. Okay. So this is equivalent of summing delta H of the reactants minus delta H of the products. Okay, and that's how we get our bond dissociation energy. So let's do that. Now, we're going to take advantage of values we've already done. We've done a previous calculation where we've calculated the bond energy in diethyl ether. So we know that value, and we found it to be 5,542 kcals per mole. I'm going to leave the units out for now, run the arithmetic and put the units at the end. So that's one of the reactants. The other reactant is oxygen. Now notice we have 6 oxygens here. So that's 6 times the value of a CO bond. So that's going to be 6 times 498 from the table. Okay, so we're going to put these together. We're going to leave the units out now just for convenience, and we'll put them back in at the end. And so we're going to subtract the bonds on the product side. And so here we have 4 carbon dioxide molecules here. So we take a look at the carbon dioxide molecule. We can calculate that as well. And what we found is that 1 carbon dioxide has a value of 1610. We've gone through that in another calculation. So what we'll do here is we'll take carbon dioxide. We have 4 in a balanced equation. So it's going to be 4 times one of these has a value of 1610 kjoules per mole. We're going to leave the units off for convenience. For now, we'll put them back into the end. So here, that's going to be plus water, and we've already calculated 1 water is 928 kilojoules per mole. Let me see if I can clean that up a little bit for you. 928 kilojoules per mole, and we have 5 of those. Okay, so if we take this and we put all these numbers together, take the left side minus the right side, when we do the rest of our arithmetic, we discover that what we have is that our bond dissociation energy is negative 2,550 kcals per mole. This part here is just math, so you just do the math either in your calculator or by hand. The key is to sum up all the energy within each of the molecules, and you do that by looking at the table and taking the values of each of the bonds. Note your stoichiometry. For example, oxygen was 6, here's 4 carbon dioxide, and there's 5 waters here. Okay, so you pay attention to your stoichiometry, put in the values, and you run them through in your calculator or by hand. And don't forget to finish with your units. So there you have it. That's how we do bond energy and bond dissociation energy.